To move on to our next numerical summaries of data, which I believe most of you are aware about. With this one, we are not going to spend so much time on this. Now, once we are talking about numerical summaries of data, we are looking at visual. We are trying to say that visual summaries of data are excellent tool for gaining information of insight into data. Okay, but more formal data analysis requires often calculation and interpretation of numerical summaries of measures. So with this one, we try to estimate or summarize the data with regards to some known quantities that will have to say more about the data. So with this, we are going to look at some such as the measures of central tendency, where under this we are going to look at the mean, the median, as well as the mode. I believe we are all familiar with this term, so this is not going to be so much of a headache. Now, in the case of measure of variability, we did talk about this, I mean, like virtually the whole semester. And once it comes to this, we are going to look at the standard deviation as well as the variance. Now, in the measures of deviation from normality, we are going to look at two popular terms, such as the skewness and as well as what we call the kurtosis. Now we will also look at the maximum, the minimum, and the range, and all this has got to do with the spread of what the distribution, how the distribution spreads along this. It's let's say the distribution. Okay, so we are going to look at these. Okay, so looking at the measures of central tendency, the first one happens to be the mean, popularly known as the average. Okay, now with this, we are all familiar with this term, and all this that we try to do is to sum up the observations that we have and divide by the total number of observations, which is designated by this formula that we have here. Okay, so suppose that we have this distribution that is 3, 5, 7, 6, 8, 9, and we are being asked to estimate the mean. All that we have to do is just sum all the observations divided by the total number of observations. In this case, which is 1, 2, 3, 4, 5, 6, 7. So that is why we have 7 here. And if you should simplify this, we are getting 6.14 to be the mean, which is as easy as that. And also, we can think of estimating the median, which happens to be the middle number. Okay, so with this, once you've been given a set of data or a set of distribution, all that we have to think about is to arrange this either in ascending or descending order of magnitude. Okay, now if your number of observations happens to be odd, it means that we would have a very clear chance of estimating our median. But in cases where you are being given a distribution which is even a number, it means that you will have to find for these two where you can estimate the mean values of the two middle numbers, and definitely that is going to give you your median. So using the distribution that we were given earlier, that is a 3, 5, 7, 5, 7, and 9. Now the middle number happens to be 6, and in this case, before we can get that, it means that we would have to what? Arrange our distribution in ascending order of magnitude, and in that you can see that this 6 happens to be our median. Okay, so that is as simple as that. Okay, now the mode is simple. That happens to be the most frequently occurring value. Okay, so given our distribution, we can see that we have 5 in there happen to occur twice, which happens to be more than any of the other values that we have. So in this case, 5 happens to be our mode, which is so easy. Now, with this said and done, with this central tendencies, let's look at some real variability, that is variability among the mean. So once we are talking about the variability, assuming that we should have a set of data points, and if we are able to draw some sort of a mean line between these data points, how are they going to deviate, or how are they going to differ from this mean line that you've drawn? Okay, so for instance, suppose that we should have a data point and we have so many data points in there. Okay, Sorry, we have so many data points in there. Now, at the end of the day, if we are able to calculate our mean and we are able to draw our main line through, now the deviation from this to this, from each point to the other, that is exactly what we are about looking at now. Okay, we are going to look at these deviations and that. Now, in the area of statistics, once it comes to measuring the variability within a data set, one, or should I say two, most important statistics come to mind. That is the variance and that of the standard deviation. And very soon we are going to see how this is being calculated. So without much ado, let's take a look at the variance. Now, if you are trying to estimate the variance, it's somehow, or should I say, very easy. This variance, which is being designated by the sigma, which looks something like this, or at times being written as this, is equal to 1 over n minus 1, and this n happens to be the number of samples that you're looking at, and the summation of each observation minus their mean or squared, and this is just going to give you that. Okay, so let's get to see how we get to solve this on board.
Variance, or should I term variance? Okay. Now, basically, once it comes to mathematics, most people would like to refer this or using this parameter, that is this sigma squared, or others would like to use what? Just a square. Okay. Now, any of these goes, okay. The most important thing is just get to know which variable or which symbol you are using. Okay. So we are just going to use this. Now this variance we see here is just equal to 1 over n minus 1. The summation from I equal to 1 to n. Then we just have to find the difference between the x, okay, as well as their mean. So just sum all this. Remember, all this is what? Square. Okay. Now this is just going to help us determine the variability between the observations within a single variable. Okay. So once we have this, in order to estimate our standard deviation, all that we have to do is just take the square root of this. Okay. Now in taking the square root of this is the same as sigma square. Remember, this is equal to variance, and we are finding the square root, and all this is going to just give us what? The standard deviation. Okay. Now, just as we use sigma squared to represent variance, this standard deviation, because we are squaring or finding the square root, this is just going to cancel out the square. So the operator for this standard deviation or the symbol, we can just use this or just what? S. Okay. So these are the two things that we shall need for now. Okay. So let's take a look at the demonstration of this. And in doing so, we are just going to take some sequence of numbers. Okay. So suppose that we have this distribution. So we have 3, 5, 7. We have another 5. We have 6. We have 8. And we have 9. So we know we have 1, 2, 3, 4, 5, 6, 7. So we have 7 numbers. Okay. Now, suppose that with this distribution, we like to determine the variance of this distribution. Now, remember from this formula, the most important thing for you to look at for here is what? The mean. Okay. Now, remember that the mean, which we know to be x bar, is equal to that from our secondary school days. We have this to be 1 over the total number of observation, sum of all the x arcs. Okay. So in this case, our main thing here implies that 1 over 1, 2, 3, 4, 5, 6, 7. So we have 7 numbers. Then times the summation of all this, which is equal to 3 plus 5 plus 7 plus another 5 plus 6 plus 8 plus 1, 9. Okay. And finally, once we do this, this is going to be a 6.114. Okay, so this happens to be our mean. So to save space, let's clear all this and let's write the 6.114 to be our mean. Okay. Now, in estimating this variance, okay, all that we need to do is just sum each of the deviation minus what? This mean. After that, we square it, okay? So we find the variance. Let me write it here. Which is the same as the sigma squared, or just what? X. This will be equal to 1 over n minus 1. And remember, our n happens to be 7. That is the total number of observations that we have. Okay? So this is going to be 7, remember, minus 1. Then we are just going to sum everything that we have in here, okay? So with this, let's write it as the first observation, that is equal to 3, minus the mean, which we have to do at 6.14, all squared. So we have this all squared. Now remember, it's a summation, okay? So you have to do this for each of these observations. So the next one happens to be 5. Minus the mean, which is equal to 6.14, all squared, plus the next observation, which is 7, minus 6.14, all squared, okay, and going further back, plus 5 minus 6.14, all squared, plus 6 minus 6.14, all squared, plus 8 minus 6.14, all squared, and finally 9 minus 6.14, all squared. Okay? So this is just the notation for all this expression that we have here. We are going to sum from each of the equations up to our last equation, and that is what you see here. Okay? Now once we go through all this, or we try to simplify this, this is going to just lead us to 4 minus 1, 4, 3, 9. Okay? Now this happens to be the variance of these 4 data sets, that is this distribution. Now with it said and done, let's see how we get to estimate the standard deviation. Now remember, with the standard deviation, which is this, the sigma without any square, which is the same as the square root of these variables. Now remember, we've been able to estimate our variance to be 4.1429. So for us to get our standard deviation, all I have to do is just find the square roots of this. So in doing so, our standard deviation becomes square root of 4.1429, and this gives us 2.03514. Okay? So with this data set, this happens to be our variance, and this happens to be our variance, and this happens to be our standard deviation in the data set. Now looking at this variance, this talks about the degree of variability we have in this data, which is quite some kind of high. Now if we should look at from the mean point of view, we have our mean to be 6.14 and our variance happens to be somewhere like 4.14. Now they are somehow close, but let's see. Once we have a real life example, we have been able to make a meaningful reduction, okay, of this. But the ideal thing is for a data to be less variable, this variance don't need to be closer to what this mean value that we have. And looking at it, this is somehow close, which means that there's some level of variability in that. Okay? The same explanation is being used for the standard deviation, but this standard deviation is more or less like the overall of the data set. Okay? So something just like this. Okay? So that is how we get to estimate the variance in that of the standard deviation of data sets. Okay? Now, for us to demonstrate this practically, let's take a look at one nice example, okay, which we encounter most often once it comes to the field of engineering.